So welcome to this video series on aptitude presented by Mentors4ias in association with Bangalore IAS Academy and NammaKPSC. So in this particular session, we will be dealing with problems based on trains. Now, problems based on trains are actually very common in your competitive exams, even in your CSAT or even in your KPSC. It is very much possible that you might get problems on trains. But as long as you understand the concept of time, speed, and distance, we've already solved so many problems based on time, speed, and distance. So you should, as long as you understand this concept of time, speed, and distance, you should be able to solve problems based on trains as well. Now, before moving on ahead, there are few things that you must understand when it comes to problems on trains. But at the same time, if you've not gone through previous problems of time, speed, and distance, you might find it a bit difficult to solve problems based on trains. In this particular session, I'll actually be solving very simple questions based on trains so that everybody is able to follow, everybody is able to understand. Now, before moving on ahead, let me just give you a brief example as to the different kinds of problems that you have, okay, or an example of a problem based on trains. So take a question here. The question could be that there is a train, a train is running at 60 kilometers per hour. A train is running at 60 kilometers per hour, and this train crosses a pole. This train crosses a pole in 9 seconds. Just imagine, there's a railway track and there's a train which is moving in this direction, and there's a pole over here. The train, as it moves, it crosses a pole in 9 seconds. Then what is the length of the train? What is the length of the train? What is the question saying? There's a train which is moving at 60 kilometers per hour and it crosses a pole in 9 seconds. Then what is the length of the train? Now, I've told you that problems based on trains is nothing but based on the concept of time, speed, and distance. When I say time, speed, and distance, what comes to mind? Nothing but time, speed, and distance. The relationship between time, speed, and distance. Now here, the question is asking for the length of the train. We have to find the length of the train by making use of the relationship between time, speed, and distance. Now let me just explain this to you. See here, imagine this to be the train. Okay, so there's a train. Now obviously a train will have a substantial length. A train could be around 300 meters, 400 meters, or 500 meters. Now this is actually a train which is actually running in this direction. Okay, this is the train. Here we have a pole. We have an electric pole or whatever it is. We have a pole. Now the question is saying that the train is running at 60 kilometers per hour and it crosses the pole in 9 seconds. So what is the length of the train? We have to do this by making use of time, speed, and distance. Now this problem is actually very, very simple. We only have to take d is equal to s into t, where the distance is nothing but the length of the train. Speed is already given as 60 kilometers per hour. Time is given as 9 seconds. So this will be nothing but 60 into 9 by 3600, because it is in terms of seconds over here. So this is gone. 60 by 60, 3 3s are 9 and 3 20s. So it is nothing but 3 by 20 kilometers. 3 by 20 kilometers, you can convert it to meters. Now, why am I taking the length of the train as distance? Why am I taking the length of the train as distance? The reason being that, see here, the pole is negligible in length. See, it has height, it has width, but the length of the pole is negligible when compared to the length of the train. So we are not going to consider the length of the pole at all. Now, in order to determine the length of the train, say for example here, now take this example. Now the train is moving, okay? So now the train's front portion is here. It has reached the pole. It has reached the pole. Okay. Now the question says in 9 seconds the the train crosses the entire pole, crosses the pole. Now when the question says that it crosses the pole in 9 seconds, what does it mean? Meaning the rear end, this end of the train in 9 seconds will be here. Will be here. After 9 seconds, this end will be here. What does this mean? In 9 seconds, the rear end of the train has covered what distance? It has covered this distance. What is this distance? This distance is nothing but the length of the train itself. Therefore, distance is nothing but the speed into time taken to cross the pole. You'll understand this more and more as we move on ahead, as we solve more and more problems. But before we start with the problem, there are a few things that I want you to understand. Okay, so first thing is, again you'll understand it better as we move on ahead, but let me just, since this is the first video on time on problems based on trains, let me just make it very clear to you. Okay, the first thing what I want you to remember is that when a train crosses a stationary man, when a train crosses a stationary man, a pole, a lamp post, a stationary car, whatever it is, in all these cases, the object which the train crosses, is stationary. The object which the train crosses is stationary, and the distance traveled by the train is nothing but the length of the train itself. It is nothing but the length of the train itself. Second case, when a train crosses a platform, a railway platform, a bridge, a tunnel, or anything like that, the object which the train is crossing, that is in case the railway platform, the bridge, or the tunnel, is stationary. Then here also the object is stationary. But in this case, the distance traveled will be equal to the length of the train plus the length of the object. Length of the train plus length of the object. The third thing the third case what I want you to know is, when a train crosses a car, a bicycle, a running man, the object that the train is crossing is now mobile. The object that the train is crossing is now mobile. But the distance traveled by the train will still remain the length of the train itself. Why? Because their length, the length of the object is negligible. The length of the object is negligible. And finally, the fourth case, when the train crosses another train, then once again the object that the train is crossing, that is nothing but the other train, is also mobile. Then the distance traveled will be the length of one train as well as the length of the other train. So it is the combination, the summation of the two lengths. Now these are the different scenarios that you'll get. You'll have a better understanding of this when we solve more problems of such types. Apart from this, going back to relative speed, when we were solving problems on time, speed and distance, I did mention whenever you have two entities which are moving in opposite direction or moving away from each other or moving towards each other, you always take what? You take the summation of the speeds. So similarly, when two trains or a train and a mobile object like a running man or a car, they are moving in the same direction, then the relative speed, they're moving in the opposite direction, then the relative speed will nothing but be the sum of the two speeds. Similarly, when two trains or one train and a a running man or one train and a car, they are moving in the same direction, then the relative speed will be the difference between the two speeds. Okay, so if you've not gone through the video where I explain the relative speeds in time, speed and distance, I suggest you go through it so that you'll have a better understanding as to why we do summation of speeds and why do we take the difference of the two speeds. So these are the few things that you want that I want you to remember. If not, you'll understand it better when we solve more problems. So what I'm trying to say here is that see here, let me just classify it into four cases over here. Okay, now what are the different kinds of problems that you have? When the length is negligible, there is no length and there is no speed. Okay, what are the cases? When the object that the train is going to cross is a lamp post or a standing man, a stationary man, a tree, or a milestone, for example, a milestone. This is there is no length, there is no speed. Second case, you have length but there is no speed. There is no speed. The object that the train is going to cross has no speed. For example, your platform, railway platform, a bridge, a train, or sorry, a tunnel, or another stationary train, a stationary train. That is your second case. Third case is where you don't have length but you have speed. You have speed. When do you have this situation? For example, a running man, a moving car, a moving bicycle, bike, or whatever it is. And finally, you have length, you have speed as well. When does this situation arise? When you have two moving trains. When you have two moving trains. So questions when it comes to questions based on problems on trains, it will be based on these four conditions. The questions may be twisted here and there, but as long as you understand this, you should be able to solve all the problems. As long as you understand the concept of time, speed and distance, you should be able to solve all the problems. So what we will do is, we will now straight away start with solving of problems. We'll straight away start with solving of problems. At the same time, I would also suggest or request you to visit NammaKPSC.com to go through the materials in the different general studies materials, the current affairs magazines which are available, the online test series which are available. If you're preparing for your KPSC exams, the Karnataka yearbook which is available, and also the other YouTube videos that we have under in our channel. Okay, so without wasting more time, let us start with the problem. Now, the first question. The first question says, a train of length 110 meters long is running at 60 kilometers per hour. In how many seconds does it cross a telegraph post? Now, while explaining the concept of problems based on time or problems based on trains, I did explain this particular concept itself. I did explain this particular scenario itself. So a train has a length of 110 meters and it crosses a telegraph post. It will cross a telegraph post. Just a second. Okay. So here we have a train. Okay. And here we have a telegraph post. Here we have a telegraph post. So the length of the train is 110 meters and it is moving in this direction at a speed of 60 kilometers per hour. So in how many seconds does it cross the telegraph post? Now we can again solve it by making use of time is equal to speed by distance, because the question is asking for how many seconds, that is how much time does it take to cross the telegraph post. So if the question says how much time it takes to cross the telegraph post, meaning what? See here, now this is the front end of the train. This is the front end of the train. This is when the time starts. After that, how much time does it take for the rear end to reach here, to reach this location? Okay, now since the length of the pole is very less when compared to length of the train, we are going to consider it to be negligible. We will not take into account the length of the pole. So here the time taken for the train to cross the pole is nothing but the time taken for the rear end of the train to cross this distance from here to here. And what is this distance? This distance is nothing but the length of the train itself. Therefore, we take distance, sorry here, my mistake, distance by speed. We take the distance as nothing but the length of the train. So, the time taken will be nothing but distance, which is nothing but the length of the train. Here it is given in terms of meters. So 1 kilometer is nothing but equal to 1000 meters. Therefore 110 meters is equal to how many kilometers? Nothing but 110 divided by 1000 is equal to 0.11. So time taken is nothing but 0.11 divided by the speed of the train, which is equal to 60 kilometers per hour. Therefore, the time taken is 0.11 divided by 60 hours. Now look at the options over here. Now the options are in terms of seconds. Then we have to convert hours into seconds. We know that 1 hour is equal to 60 minutes, which is equal to 3600 seconds. Then if 1 hour is equal to 3600 seconds, 0.11 divided by 60 hours is equal to how many seconds? Nothing but 0.11 by 60 into 3600. This is 60 times. So what do we get? We get 0.11 into 60, or this is nothing but 6.6 seconds. Therefore, the correct option is D, and the correct answer is 6.6 seconds. See here, you have to see everything is in terms of 6.6 or 60 or 66 and 6. If you don't take care of the decimal point, if you're not giving importance to the decimal point, instead of 6.6 seconds, you may get the answer as 0.66 seconds or 66 seconds, and you will end up marking the incorrect option. So please give importance to the decimal point, the position of the decimal point, so that you are able to get the correct answer. Okay, next problem. Question number 2. Question 2 says a train is running at 60 kilometers per hour. In how many minutes does it cross a bridge of length 150 meters if the length of the train is 100 meters? Now see here again, the same situation. We have a train over here. Okay, we have a train. Now the train is running in this direction. The train is running in this direction at a speed of 60 kilometers per hour. Now the question is saying the train which is running at 60 kilometers per hour is now going to run over a bridge of length 150 meters. Now there is a bridge. Okay, so there is a bridge now. Now the train is going to run over this bridge. The train is going to run over this bridge of length 150 meters, where the length of the train itself is 100 meters. So the question is asking how much time does it take for the train to cross the bridge entirely. Once again, this can be solved by making use of the same thing, same relationship, time is equal to distance by speed. We have to find out time. Speed is already given as 60 kilometers per hour. But what is the distance now? Here distance will be the length of the train plus the length of the bridge. Why? Because the question is asking for how much time does it take for the entire train to cross the bridge. Meaning what? Here this is the rear end of the train. This is the rear end of the train. How much time does it take for the rear end of the train to reach here, all the way from here? So this is our point of origin, this is the point of destination. How much time does it take for the rear end of the train to reach from here to here? Meaning it is covering what distance? It is covering the distance of nothing but the length of the train plus the length of the bridge, which is 100 meters plus 150 meters. This is equal to 250 meters. Therefore, distance is 250 meters. Then how do you determine the time? 250 meters, or since speed is in kilometers per hour, we'll take it as 0.25 meters. 0.25 meters divided by 60. So the time taken is nothing but 0.25 by 60 hours. But look at the options. Everything is in terms of minutes. So 1 hour is equal to 60 minutes. Therefore, 0.25 by 60 hours is equal to how many minutes? What do? We multiply 0.25 60 by 60. 60 gets cancelled. The answer is 0.25 minutes. So the correct option is option B. The correct answer is 0.25 seconds. Okay, we'll move on to the next question now. Third question. The third question says a train of length 100 meters is running at 70 kilometers per hour. In how many seconds does it overtake a man running at 10 kilometers per hour? Now, since the question is saying overtake, what does this mean? Both the train and the man are moving in the same direction. That is why the question says the train is going to overtake the man. Now, if you remember relative speed, the problems based on relative speed from time, speed and distance, I did mention whenever two things are moving in the same direction, and I also mentioned in the initial explanation of this particular session, whenever two things are moving in the same direction, what do? We take the difference of the speed. We take the difference of the speed. So now the question is asking for time, where time is nothing but distance by speed. Here, since we have two moving objects, we'll have to consider their relative speeds. Since both of them are moving in the same direction, we have to take their difference. That is speed of the train minus speed of the man. So speed of the train is what? 70 kilometers per hour. Speed of the man is what? 10 kilometers per hour. Now what is the distance? Since the length of the man is negligible when compared to the length of the train, the distance traveled, we'll take it as nothing but length of the train itself, which is 100 meters or 0.1 kilometers. Therefore, time is equal to 0.1 divided by 70 minus 10, which is equal to 0.1 divided by 60 hours. The question is asking for time in terms of seconds. What do? We'll multiply it by 3600. 60 into 60 is 3600. 0.1 into 60 is nothing but 6 seconds. Therefore, the correct option is option A. Correct answer is 6 seconds. If you don't take care of your decimal point, the position of your decimal point, you might make mistakes. So please take care of it. Here the correct answer is 6 seconds. Answer is option is A. I hope you understood this. Let us move on to the next question. Question number 4. Now, question number 4 says a train of length 65 meters is running at 70 kilometers per hour. Another train of length 35 meters long is running at 30 kilometers per hour speed, but in opposite direction. In how many seconds do they cross each other? So what is the question now saying? There are two trains there are two trains, okay, and they are moving in opposite directions. One train is of length 65 meters, which is running at a speed of 70 kilometers per hour. The other train is of length 35 meters, which is running at a speed of 30 kilometers per hour in the opposite direction. So in how many seconds do they cross each other? Now, again, time is nothing but distance by speed. Here we have two moving objects, then therefore we have to take their relative speeds. Whenever we have two objects moving in opposite directions, then the relative speed is nothing but the summation of the speeds. Therefore, it is length of train 1 plus, speed of train 1 plus speed of train 2. S1 is equal to 70 kilometers per hour, S2 is equal to 30 kilometers per hour. Next, the question is, what is the distance? What is the distance? Now here, since both the objects have considerable length, that is, this train has 65 meters and this train has 35 meters, then the total length here will also have to be the summation of the two moving objects, that is two trains. Then the total distance will be the length of train 1 plus the length of train 2. Here we cannot neglect the length of the second train. Earlier we used to neglect the length. If it was a man or if it was a pole, we used to neglect its length. But here we cannot neglect the length because it is also considerably long. Therefore, the total distance will have to be length of the first train plus length of the second train. Then what is time over here? Time is nothing but L1 plus L2 divided by S1 plus S2. What does this entail? 70 kilometers per hour, sorry, my mistake. Length 0.65 meters, because we are taking it in terms of kilometers, plus 0.35 meters divided by 70 kilometers per hour plus 30 kilometers per hour. What do we get? 0.65 plus 0.35, or 65 meters plus 35 meters is what? It is 100 meters, or 0.1 kilometers divided by 70 plus 30 is 100 kilometers per hour. So 0.1 by 100 hours is our answer. Again, all the options are in terms of seconds. If we have to convert 0.1 by 100 hours into seconds, what will we do? We will multiply by 3600. 0, 0 cancelled. 36 into 0.1, what do we get? We get 3.6 seconds. We get 3.6 seconds. Therefore, the correct option is 3.6. It is option B. Correct answer is 3.6. Again, if you look at the options over here, any small mistake in decimal point, you will go wrong. Under pressure, you will mark the incorrect option. Instead of gaining marks, you will end up losing marks. So therefore, the correct answer is 3.6 seconds. Let us move on to the next question. Question number 5. Now, question number 5 says, a train is running at 60 kilometers per hour. If it takes 6 seconds time to cross the telegraph post, find the length of the train. Now, the question is asking for distance instead of time. The time has already been given as 6 seconds. Now, compare this to the first question that we solved. In the first question that we solved, the question was asking for the time where the length of the train was given and we took distance as length of the train. The speed of the train was also given, and therefore we found out that we determined the time taken to cross the post. Here once again, negligible length, so we will not take the length of the post into account over here. So now we have to determine the length of the train. Length of the train is nothing but distance over here. Then what is distance? Distance is speed into time, where speed is 60 kilometers per hour and time is 6 seconds. Since the speed is in terms of hours, we will convert seconds into hours. How do we do that? 6 divided by 3600. See here, 1 hour is equal to 3600 seconds. Then how many hours is 6 seconds? Nothing but 6 into 1 divided by 3000, sorry, not 36,000, 3600 seconds. Therefore 60 into 6 by 3600. 60 times 60 is nothing but 3006 seconds. 6 tens are 60, 1 by 10, or D is equal to 0.1 kilometers. D is nothing but 0.1 kilometers. 0.1 kilometers means how many meters? 0.1 kilometers is nothing but 100 meters. See here, 1 kilometer is 1000 meters. Therefore, 0.1 kilometer is how much? Nothing but 0.1 into 1000. It is 100 meters. Therefore, distance is 100 meters. If distance is 100 meters, it means length of the train is equal to 100 meters. I'm sorry, all these problems, I've been very shabby in solving them. It's not very neat or legible. But I hope you understood. As long as you understand, that is more than enough. So, length of the train here is 100 meters. So, it is option D. The distance is nothing but length of the train. So, the correct answer is 100 meters. It is option D. So, here we have solved 5 problems based on that is problems based on trains. I hope you've had a better understanding. If possible, we can still solve more problems based on trains so that the entire concept is once again clear. But again, if you've not gone through all the problems based on time, speed and distance, I suggest you to go through them. After that, go through problems based on time, speed and distance, problems based on trains. Then try to do the practice questions over here. Okay, so the answers for the practice questions will be posted in the comment section. So here the answer has to be in kilometers per hour, here the answer has to be in meters, here the answer has to be in seconds. Try to find the answers will be posted in the comment section. So thank you for watching this particular video. If you do have any doubts, please do write those in the comment section. As and when possible, we will reply to it, give the solution to any of the doubt that you have. Thank you very much. Do follow us for further such videos.